Hey everybody, this video is going to talk about using the rational zeros theorem to find all zeros of a polynomial, even if there's complex zeros. So remember that if there is a rational zero, any possible rational zero is going to be of the form plus or minus 1 over plus or minus 7 over plus or minus 1 over plus or minus 2, or P over Q, right? You can go back and watch the video on that. So it's got to be of the form plus or minus 1, plus or minus 7, or plus or minus 1/2, and plus or minus 7/2. So we're going to check each of these until we get a 0. Okay, so check numbers until you find a 0. I know, based on my preparation, that 1/2 is a 0, so let's double check. For synthetic division, we put down these coefficients. Bring down the 2. 2 times 1/2 is 1. -5 plus 1 is -4. -4 times 1/2 is -2. 16 plus -2 is 14. 14 times 1/2 is a positive 7. So yay, I do get 0. And this means that f of x equals x minus my 0, which was 1/2, times my quotient, which is 2x squared minus 14x. Sorry, minus 4x, I got ahead of myself there, minus 4x plus 14. Okay, guess what? This is prime and doesn't factor. So what do? We do that negative b plus or minus the square root of b squared minus 4ac, the quadratic formula. If you want to hear me singing the song, go see my previous video. So that means my other zeros are of that form. So negative b is 4 plus or minus the square root of b squared, -4 squared, minus 4a, which is 2, and c, which is 14, all over 2a, or 2 times 2. We're going to end up getting 4 plus or minus the square root of -96 over 4. After some simplification, we'll get 4 plus or minus the square root of plus or minus 4i times the square root of 6 divided by 4. Now remember, each of these pieces is being divided by 4, so simplify a little more and we get x equals 1 plus or minus I square root 6. So what are our zeros of the function? Well, our zeros are 1/2, which we found here, and then 1 plus I square root 6, and 1 minus I square root 6. And there's our answer. We found all of the zeros of this function.